Hi, good day, everyone. Welcome to our webinar on Proceq RQ8000 role tester. My name is Maria, and I'm the product marketing manager for Screening Eagle Technologies based in Singapore. If you have any feedback or questions, there's an email address that you can use to contact me. Today, we are very pleased to have three expert speakers: Dr. Dariush Bernat from Screening Eagle Technologies in Switzerland, and two colleagues from our technological partner, Tapio Technologies in Finland, Mr. Ilkka Mustonen and Mr. Kim Kingas. So before we start with the lecture, I will give a brief introduction to Screening Eagle Technologies, for those of you not familiar with our company. So Screening Eagle Technologies was founded in 2019 and is the merger of Proceq, a leading NDT manufacturer since 1954, and DreamLab, a software and robotics company headquartered in Singapore. We have over 200 employees in 8 country offices across the world and many distributors in other countries. Here you can see a snapshot just on one slide of all the solutions we provide. So we provide sensors and software for inspection. So this is for different sectors, including concrete, roads, geomatics, metal. And today we'll be talking about some of our industrial testing equipment. So in this category, we have gloss meters and also roll testers. And today we'll be talking about one of the roll testers, which is Proceq RQ8000. So before I pass over to Dr. Dariush Bernat, who will start the lecture, I'm just going to launch a small poll, just asking you simply what sector you're from. And this will help us to understand our audience better and also to plan for future webinars. Dariush, could you share your full screen, please? We can see the presenter view. Oh, perfect. Okay, the floor is yours. And the audio, Dariush.
Right.
Perfect.
Perfect. So apologies for this little inconvenience. Right. So I would like to welcome everyone in today's webinar. I hope you will enjoy the presentation that we have prepared for you. Today, we will show you how you can improve your quality processes, how you can minimize your waste of the materials, machine downtime, and gain higher customer satisfaction. Before we jump, I would like to very shortly discuss and show you how does the hardness testing of rolls work on a very simple example. So here what you see is the roll, and for this exercise, we will use our LEAP-T method that is based on the rebound. So the hardness testing principle works in a way that a specific device, which is here a coil, loads a hammer or in this case, an impact body, and shoots this against the surface of the roll. What is being then done is we collect very specific points across the entire roll, and when we collect that data, as a result, we receive a hardness profile. So in other words, we can really scan the entire roll and see what areas are harder or softer, and later on we'll show you why this is of high importance for the roll processing and roll manufacturing. In this simple example, we'll see how the leap U values are calculated. This is one of our products. In other words, what we measure is the rebound velocity. Let us now jump very shortly to our portfolio. We're proud to announce that the Screening Technologies, Proceq, has the most complete hardness testing portfolio on the market. We have three main products: the RQ8000, our very recent product that we have launched together with our technological partner Tapio. We have also Equity 550 Leap U and the Paperschmidt. Let me very shortly discuss what are the differences of these testing devices and what device would be best for your application. So the main measurement principle for these three methods is the rebound. However, the RQ8000, the product that we're going to concentrate today at, uses slightly different feature, which is deceleration. In other words, we measure the opposite force of the acceleration, so how much the impact device, in this case it would be the hammer, is being slowed down. All of these three methods have slightly different sampling principle, starting from the RQ8000, which is measured optically, then Leap 550U, which is an inductive coil, and the Paperschmidt, which uses optical sensor. Now, the third option that I would like to discuss is the impact energy, starting from very low impact energy through medium up to high, and the measurement frequency. The RQ8000, it's a fully automatic device and measures with 30 Hz per second. The Equity 500 Leap U measures with average frequency of 0.5 Hz per second, 0.5 Hz, excuse me. And this is an average value based on how quickly users can charge the device and go to another spot. Obviously, this number can be higher depending on how user is trained. And lastly, we have Paperschmidt with 0.8 Hz. Important to highlight our different features. So the length resolution, the most accurate device we have is the RQ8000, which has the length resolution of 0.1 centimeter, then the Leap 550U, 5 to 15 centimeters, and similarly the Paperschmidt, 5 to 15 centimeters. However, nevertheless, these are the most important features that you would like to know: the impact energy and the measurement frequency. Important to highlight is also the software. All of our devices support Windows 7 software or higher, so you do not require any upgrades in your offices, factories, and plants. The last thing I would like to discuss on this slide is the user dependency. We all know that some devices have different user dependency depending on how user is skilled. The RQ8000 is a fully automatic device. It has ultra-high, no user dependency, and as you will later see, it is extremely easy to use. The Leap 550U offers very good user dependency, and the Paperschmidt, due to its length and sometimes the angle in which the impact is imposed, also shows a good user dependency. Now, many customers ask us, what materials can we test? So we prepared this slide for you to give you a highlight of what you can measure. Basically, all of our devices are suitable for paper rolls, whether these are large or medium ones. For the small rolls, we would suggest, for example, RQ8000 and Paperschmidt. Nevertheless, most of the products actually shall be tested at the factory because suitability of the device really depends on the machine, custom materials that are being processed, and also the operators. Now, if we jump to another transparency, let me highlight what these devices can offer to you. First of all, cost savings. The hardness testing of rolls enables you fast and easy detection of defects before they accelerate, or for example, before you process the roll till the end, before you ship the roll to your customers. And because you can react very early, you can generate massive savings on raw materials, also a machine downtime, manpower, and you know well how this can actually increase the material cost and the entire processing. Not to mention about the customer satisfaction, because at the end, actually, you have less warranties, you have less problems with processing. Also, all of our devices, they have very good user independency. That means that if you pass a device to another user, you will have similar or exact same results. And because all of our devices can test multiple materials, starting from paper to cardboard, aluminum foils, plastic films, they are suitable for clients or industries across the paper and roll testing products. Now, let us jump very shortly to the application and benefits of our main feature here, which is the RQ8000, and I will briefly highlight what this method can offer to you and what are the specific features. Here on the right-hand side, what you see is a presentation of our device. This is the RQ8000. This is exactly the same device which I'm having in my hands here. This device is similar to rebound method, but uses deceleration. Nevertheless, the device has also the feature to measure exactly in the same way as LibView or Paperschmidt, which we'll highlight later. This device has extremely high resolution, which is being optically measured with very high sampling rate. And now the question is, what can you use it for? So the device enables reliable measurements of rolls through the deceleration, and you can use it, practically speaking, for any part of your quality processes, starting from roll processes, customer rolls quality control, parent wheel testing, machine roll control, non-destructive testing of end rolls. And what are the materials? Paper, aluminum, plastic, composite, complex materials, and films. All of these can be addressed with this device. The device also features a very simple user interface, because it has just two actually buttons, the power button and the scanner. So this is actually the top of our device. On the left-hand side, you see the USB-A/B slot, which allows you to transfer your data through the cable. Nevertheless, if you wish, for example, to transfer them through the SD card, you have also this chance to remove the card and plug it back to your device. The device also uses Bluetooth feature if you would like to have, for example, automatic data transfer, and you can use this in line with a tablet, so your data will be displayed almost instantly. And in front of this device, you will find also a very important feature, which is a multi-format barcode and QR scanner. You can scan pretty much everything, QR codes, also the barcodes. Here you see also fall fit, which also support non-measurement method. I will tell you about it later. And this is also a protective stripe mount that can help you to minimize the wear of the surface through the measurement, so you can save much more material during the testing. Now, the key benefits of our device is automatic data acquisition and transfer. Because RQ8000 is a fully automatic device, the only thing what you need to do is to press and scan the roll of the scan the roll. Kim is going to show you this a little bit later. What does it give you? It eliminates the human error during the measurement, because it's simple as irony. Place, scan, download the data. Another thing is very low impact. It's delicate yet sensitive, so it allows you actually not only to save the surface and minimize potential waste of the material during the measurement, but also it is especially designed for delicate and sensitive films, which are complex and expensive. It is ultra precise because it hits 30 impacts per second, and the hammer of this device is actually very, very precisely measured. It provides you the detection of small defects, and if you would like to, you can also have different scanning speeds, which is here. So the average recommended scanning speed would be the 30 centimeters per second. But if you have, for example, a simple roll, you can even go up to 50 centimeters per second. And it is you, the customer, decides how fast the roll can be scanned. The last feature is the cost and effort efficient implementation. Not only the device can have all the features you're requesting, it is also very easy to integrate. First of all, because of the Windows 7 to 10 compatibility. So it supports the PCs from the past, no need to implement any extra expensive devices. It also supports a tablet, so low-cost Windows 10 tablets can be connected to this device. We also have standard AA rechargeable batteries, which are easily accessible, which you can get them anywhere without any major cost to be there. Last, the weight of this device is 1,250 grams. It allows you a one-hand operation, which is practically nothing for such a fully automatic device. We also have a Bluetooth feature. So that means you don't need to, if you want, connect this through the cable. The data can be transferred automatically to your device that you're operating with. And all of these features, they allow you to tune your device exactly to your needs. Now, I would like to move to the demonstration, and I would like to welcome Kim Kingas, who's going to show you how this device can help you, how easy it is to use. And in this presentation, we'll discuss how to initiate the device, how to start the software and the configuration, how to go to the measurement procedure, and how to manage the data. Kim, the stage is yours.
Thank you, Darius. Warm welcome from Finland. So this is Kim Kyngas, Operations Manager of Tapio Technologies, and here we have the Proceq RQ8000. I will go through in this presentation how to make a simple measurement and also show you some of the features of the RQ8000 software. Okay, so with the audio, warm welcome from Finland. This is Kim Kyngas from Tapio Measurement Technologies, and here we have the RQ8000 unit, which I will show you in this presentation how to make a simple measurement and how to operate the software, which also enables you to use some automated features to process the data. So in the package we have the RQ8000 unit, set of batteries, software, and the spare SD card. For the SD card, we can the storage will last for at least 2 weeks, so there's no hurry to connect and transfer the data to the wirelessly to the computer. So here we have the barcode reading feature of the unit. So we have a barcode for the roll, and with the red green LED blinking, we have a successful barcode reading. We just place the unit right on the edge of the roll, so we can measure right from the edge of the roll all the way through the roll. For this presentation, we have a PET plastic roll, and we also measure paper and film. We recommend to measure 3 times So we are sure that the measurement is successful. We have a comparison of 3 profiles, and they will show on the computer. I will share the screen and show you how the data is transferred. So here we have the download function, and the RQ8000 will connect via Bluetooth to the computer, and the transfer will be quite fast. In this screen we have the previous measurement that has 3 profiles shown in one screen. We also have a filtered mean and a mean of rows shown in the diagram. So here we have the hardness profile of this film roll, a bit harder on the edges and softer in the middle part. We also have a way to automatically open the measurement in the text format, so we can export it to the Excel. We have a automated opening text, and after the measurement is transferred, it is automatically opened in the text format. In this measurement file, we have all the measurement points in tab separated text format. We also have a calibration sample which can be used for checking that the measurement level stays the same during the years. So we have the barcode here, successful reading, and then we gently measure the sample 4 times, so we have more data to be filtered. Here we have the measurement itself, so barcode, and the measurement of the calibration sample. And the calibration sample profile will show that the measurement level has stayed in the original level, which we will see here. And also the text version of it. Now we have it automated. So that concludes the short presentation on how to measure with the RQ8000. Thank you.
Thank you, Kim, for a very nice and short presentation. I hope this highlights and shows how easy this device can be used, and how fast it can get you the data. I would like to move right now into the commonly asked questions. We prepared a few questions for you. These are the questions that many customers ask before, so we decided to bring them together, but also would like to show you and highlight the unique features which will differentiate this device compared to other methods and QCS systems. the very first question would be, how many layers does the RQ8000 can measure? So many customers ask questions similar to what is the penetration depth of this device, whether we can detect defects really at the core of this roll, or basically we are just measuring the hardness. And I'm recalling right now a very interesting discussion with Ilkka. And this slide actually shows you the phenomenon which is being taken place during the roll manufacturing. So in short, actually, the roll consists of many layers. So while winding or preparing the roll, there are inner layers, and there is another layer coming, and layer after layer and layer after layer. And I like to quote actually Ilkka, who said that the inner layers, if they had entire power in the world, they would explode. But the next layer, the incoming layer, actually keeps all the layers together. If you have a defect that emerges somewhere in the middle of the roll, that means that, and the compression forces, that mean that's the problem or the defect or the hardness within the profile will be accelerated and somehow multiplied. And it is somehow available quite near the surface. If there is something wrong with the roll, for example, in the middle, you will see it at the surface, because the problem might not origin from the surface per se. It might be actually located somewhere in the middle. Of course, the profile will show you the combination of the roll and the defects. But if they are defects, certainly you will spot them at the surface. Hence, the surface measurement is the method which allows you to detect them and spot them very early. Another comparison, and here I would like to ask Ilkka to tell us a little bit more, because our technology partner is also specialized in QCS systems, which is the basic weight and the caliper. And Ilkka, can you please tell us something about comparison between the QCS and the hardness testing? What are the benefits of using the hardness testing method compared to the QCS systems, which are shown here, for example, basic weight and the caliper profiles?
Thank you, Darius. Yes, here in the graph, you will see the blue profiles. And those are measurements from the QCS system. There is a basis weight on top and the thickness profile in the middle. And then we have the blue line, red line, red profile for hardness. And it is not 100% clear how the differences appeared, but the basic phenomena for QCS systems are that they are set up for the process control, and there might be, usually is, some filtering, etc. Involved, so that the very short-term variations are not so clearly seen, and this is an example where the customer had some roll corrugation type of problems, and they were not able to see it in the QCS basis weight and thickness profiles, but it was clear on the hardness profile. So the sensitivity is the main issue here, and especially in thickness measurement. The RQ8000 is superior compared to any QCS thickness measurement. So yeah, so this is just one of the examples that will separate roll hardness profile from any QCS profile. So and the photos on the right are the illustration of the problem of the customer.
I understand. Thank you. In other words, the QCS and the basic weight might not show you the defects which are present at the roll, and because of the nature how it works, the data is smoothened, is averaged because it must be, whereas the hardness testing measurement will detect such spot. I also noticed, and apologies for that, we have a little technical difficulties because we are sharing the presenter screen. I will just gently swap them for your convenience. Apologies for that. Let us jump to another slide. This is again the online QCS thickness profile. And this is the example from the cigarette box machine roll in comparison with QCS thickness. So here, am I correct, Ilka? The entire profile roll is practically missed by the QCS systems, whereas the RQ8000, because this data comes from the RQ8000, would clearly show the profile and how it varies across the roll. Is that correct?
Yes, this is a perfect example of the sensitivity of the roll hardness. You will see two clear spots right in the middle of the hardness profile, which are completely missed by the QCS system. And those are the really in, yes, you will see more dropping hardness values on the right side of the profile. And those are the really problematic areas. When the hardness is changing rapidly, either way, those are the major concerns for the end user of this paper or board. And it just goes to say that the QCS system is averaging the data, it's moving faster, and it's measuring just one layer of the production, whereas all hard measuring multiple layers, and therefore that's one of the reasons that the sensitivity is so much better.
I also wanted to highlight while showing this slide is many customers ask us, what are the limits? How should it be set? Does the device detect that? So actually, the customer has all its power to change all the parameters, to set their limits, to adjust the limits to their machines, processes, and materials they are processing. So the customer will perhaps require initially some trials to see whether the profile, for example, here will pose a problem, but certainly they will see the defects and they will see they will adjust the device exactly to the needs for the specific role or for the specific material. Now, many customers also ask us, can we compare the data between different devices? The answer would be yes and no. And here is actually a perfect example of the same role measured by the Paperschmidt and measured by the RQ8000 here. And what we are seeing here is, for example, that here the hardness slightly extends the anticipated hardness, but you can also see that for this particular role, perhaps the RQ8000 would be much better choice because it not only offers the higher resolution, but it also shows much more accurately the profile of the role. If you pay a closer look to this profile at the bottom, either on the left or on the right, you will see that these nodes or these peaks are reflected by the device. However, the sensitivity of this device actually is higher. And for this particular role, the RQ8000 would be the product that we would advise. And important to highlight is the values are arbitrary. One rather should not compare, for example, values measured with our Equatip 550 LeapU which measures in HLU, but rather compare the entire roll and see, for example, whether the soft edges or the hard spots somewhere there are matching the process and are of any danger. Is there something, Ilka, you could highlight here on this transparency, that our guests can also get some insights from the
Yes,
expert?
it's quite clear that both Papersmith and RQ8000 measure the same phenomena. However, because of the difference in sensitivity, Papersmith, although it sees the same type of variation in both profiles, it would be perhaps a little bit more difficult to define whether the changes in hardness values are significant on the Papersmith profile. So therefore, perhaps RQ8000 will be a little bit more informative. That was more or less another way to say what you just explained.
Another comparison between the Papersmith and between the RQ8000 is also displayed here. This is also clear. Perhaps this is a better example that both profiles are being measured. You can see, for example, here there is a hard spot or harder node, which is also reflected here down at the bottom, and the profile matches the profile here. So both devices could be used. Nevertheless, for this particular material, this device would show you high resolution and would highlight the spots, the defects, the problems you want to find out better. If we go right now to another transparency, so Ilka, this is the case of the demo board you've been presenting. Can you tell us a few details about this particular slide and why it is important actually to measure from edge to edge, and what potential savings it could gain for a customer?
Yes, this is actually a live case from earlier this summer. We had this customer who has this hardness profile almost all the way within the limit. I want to point out there is a average line right in the middle, and the customer can set up the upper and lower limits according to the processes and customers, what is acceptable. In this demonstration, we found out a significant hardness value decrease right there on the edge of the left edge of the machine roll. And this, although it may seem like a small issue, but with this customer, this was the reason to purchase the unit. Although this may represent just a few inches or more, for sure less than 10 inches of the width of the parent roll, it still amounts to quite a bit of money if in further processing this part of the parent roll needs to be rejected. So yes, it's a fairly straightforward calculation of the money they have lost with this issue on the left side of the roll.
So in other words, basically the customer would have to process the roll again in a way that he has to reject more or less this part on the left, approximately 10 inches, right? Yes, approximately 10 inches. So 10 inches of the entire roll would have to be thrown away. This is not only the machine downtime, this is not only the processing, manpower, but also the waste of the material, which in some cases might be actually extremely expensive. Many customers also ask us what are the software features, for example, we can change and adjust. I have prepared 2 windows. This comes from the settings. I did not display all the features you can adjust, but in other words, you can, with one measurement, or actually 3 repetitive measurements, you can measure different parameters, the deceleration, but also the velocity ratio, which is nothing else but the hardness expressed by the HLU values. You can also store settings and load them depending on customer needs. For example, if you have constant products, recurring customers, you can set up the settings precisely for this material and, for example, for that machine. You have also statistics at glance. You can filter them, you can process them, and you can also manage your data. So this slide shows only a few parameters you can fully adapt to your processes at your factories, plants, mills. The last one is also a very recent example. Ilkka, would that be, in your view, a big problem for a customer? I'm referring right now to this particular right side of this roll, and here small defects.
Yes, this is an example where the demonstration was made at the converter. This is fast food packaging material for one fast food hamburger company, and this roll was already processed, and it was ready to go through the machine that actually makes the hamburger packaging. And so all the work for this roll, even the printing, was already done. And this roll was rejected halfway after the production. So all the money spent to this roll was lost because of those variations on both sides of the roll. The left side was just outside the limits, as well as the right side of the profile. And for this customer, this type of thing, they would at least have to measure the roll there right before the last stage of the process. But actually, to save the most money, this roll could have been measured before the printing, and if there was any other step in terms of the production line. So this just highlights the importance of the roll hardness measurement. Although this seems like a fairly all right roll, it turned out that the machine that actually makes the hamburger packaging does not allow much thickness variation, which is illustrated here by the hardness profile. So again, one of the examples where this type of measurement provided the justification for purchase of the unit.
Right. So in this case, basically, this defect detected earlier on would allow to save time, money, and also quite a lot of cost, because this is the ready product.
Yes. At least right before they will start to run this roll, they should have taken the roll hardness measurement and rechecked the roll entirely. If not, this was not done before the printing.
I understand. This is an excellent example of potential savings and how to gain customer satisfaction, having less problems with the process, more control over the process. I have also a last slide to show in this Q&A session before we jump to live Q&A session. Aluminum foil is tricky because it's extremely sensitive due to impact energy. And practically speaking, the RQ8000 is the only product that you can use. However, there are some tricks regarding this one, because it can damage a little bit the surface of the material. In this case, for example, we would recommend to use the plastic stripe which is there, which also protects the surface from being damaged. The plastic stripe will slightly change the sensitivity because it also absorbs the energy. Nevertheless, in such cases like aluminum foil, we always recommend to try out the device and to test it so the users actually are 100% sure that is fully suitable for them. Is there something else, Ilkka, you would add for the aluminum rolls, because they are actually very, very tricky and expensive, obviously.
I've done a few demonstrations in Europe for the aluminium foil, but just a few of them. So forgive me, but I'm not an expert on aluminium foil. However, I've seen cases where the profile can be measured without this protective strip. But in some cases, a few layers of the aluminium foil were lost. So in those cases, perhaps it's advisable to use the strip there. Fairly straightforward application to my limited experience. Usually the hardness profile is exactly the opposite compared to paper and board profiles, where in aluminum foil cases the edges seem to be harder than the rest of the profile. But nevertheless, once you get rid of the marking effect, then it's all straightforward analysis.
I understand. Thank you very much. This was the last of our commonly asked questions by the customers. With this in mind, I would like to go to the next part of our presentation,